Welcome to the PNNL FluxTool here at the Opens Lab. My name is Cameron Whitlow. I'm a lead on the project alongside other students, including Paul Gasper and Zach Pelster, who have also contributed to the project. The FluxTool is an open source tool being developed for PNNL, Pacific Northwest National Laboratory, to measure and analyze riverbed environments via pressure, temperature, and electrical conductivity measurements of riverbed water. These measurements are taken at 5 points across the rod to gather data at different depths. I will quickly lead you through version 1 of the tool and the future design changes for version 2. The FluxTool rod was made to survive long-term in a water-filled environment, battery life of 6 months, allowing for installation in remote locations without constant checkups. Installation is easy with our modular design. The main rod can be installed with a pounder and the main electronics attached afterward with a braced head joint, creating a watertight seal. This allows for complete submersion of the tool, quick installation, and quick data and tool retrieval. While the rod is submerged, it will periodically take data samples from all of its sensors, saving them to a removable SD card in the head joint. This data comes from our osmopods, which are embedded in the surface of the rod. These pods contain small PCBs with conformal coating to protect against water and have a metal mesh to protect against debris and sediment while taking measurements. The electronics are compact and host the temperature and pressure sensor and the probes for the electrical conductivity sensor. All of this data is then sent to the main PCB in the rod for processing and storage. The second version of the rod is now in development with some key feature updates. 16 metal rings are being added to the surface of the rod across its length around the existing pods, allowing for electrical conductivity measurements across the surface and through sediment. Grooves are now being etched into the surface of the rod, allowing these rings to fit snugly inside with small holes, allowing for the electronics to be attached to the rings. Groups of rings can be selected at will to take electrical conductivity measurements between them, allowing for complete sensing flexibility. The electronics are seeing an overhaul as well. The first change is an update from a 2-pin to a 4-pin Wenner EC measurement system, allowing for more consistent EC measurements around sediment, used both in the pods and the rings. The rings are also adding many more electrical contacts and circuits, so a new method of connection is being tested. Instead of 50+ wires being fed through a very small tube, a bus consisting of wires and PCBs will allow us to have less than 10 wires in the rod, and much simpler control over sensor connections and multiplexing, allowing the controller to easily pull data from any one sensor. These PCBs easily slide into the rod and are held by a 3D printed brace. That was a quick overview. For more information about the project as a whole, more mechanical and electrical details, or data results, please take a look at our wikis for either the entire tool or just for the osmopods. If you have any questions, please reach out to me via my email. Thank you.